Today's podcast is part of our special series looking at AgricaptureCO2, an EU Horizon 2020 project with which we are involved here at Loddington, and which recognises the unique threat posed by climate change for farming, food production and society more widely. It recognises that there is a problem, climate change, but also that there is a potential solution, so-called regenerative agricultural practices. Now, AgricaptureCO2 approaches the issue of climate change from a dual viewpoint. That regenerative, more sustainable farming practices are good for the long-term health, productivity and resilience of our farm soils and therefore ultimately for farm profitability. And that such practices lead to the long-term accumulation of soil organic matter and subsequently carbon, and therefore offer the potential for farm soils to act as a carbon sink, helping to mitigate some of the impacts of climate change to the benefit of society as a whole, while also opening the possibility of allowing farmers to conduct carbon trades in future. Soil health and soil carbon sequestration are two almost infinitely complex issues which often run the risk of becoming oversimplified in debates around how farmers can both achieve sustainable productivity and help reverse the trend of climate change. And it's vital that we are realistic both in our individual levels of understanding of the topics involved and in what can be realistically achieved. In truth, we can only then set objective goals. So today I'm speaking with John Williams, Head of Soils and Nutrients at ADAS, the UK's largest independent provider of agricultural and environmental consultancy, policy advice and research and development. John is a chartered soil scientist with 30 years experience and a keen interest in soil organic materials and nutrient management. As such, there are few better people qualified to discuss how farmers can realistically go about focusing on their soils and what they can realistically hope to achieve. John, hello.
Hi, good morning.
Thanks for joining us today. So we'll get right into it. John, for a start, could you just tell us how you got into the soil game in the first place and how you've seen the awareness of soil health and management change over your career?
Wow. Well, when I was doing my A-levels and didn't have a clue what I was wanting to do, I was lucky enough to go on a university taster week at Bangor University, as it happened. And in amongst the partying, we were working with the soil science department there, going around looking at soils and parent materials in North Wales. And I found it fascinating to see how management and landscape affected the different soil properties and the way that the land was used. So on the back of that, I applied for a place at Newcastle University to do a degree in soil and land research science, and really enjoyed that. Found it great, very interesting, covering a huge range of soils related topics. And then after a spell working on a farm, I got a job with ADAS in Newcastle. Working with the field teams there, helping with land restoration projects of the open cast coal sites up there, so digging lots of holes, looking at lots of soils, and eventually got a permanent job with a wonderful organisation called the Field Drainage Experimental Unit in Cambridge as a soil scientist. And that was, a long time ago now, 35 years ago, and it's been really interesting to see how agricultural practices, agricultural policy, and the way that have changed over that time period. And
how do you feel that farmers' sort of appreciation of soil as our primary asset has changed? Have you seen any significant shift in sort of mainstream farming opinion in those 30 years?
I don't think the opinions change. I think farmers generally and absolutely understand that soil is their most important resource, and that they have to look after it. I think what has changed is the scale that farming now the farm operations take place. Machinery's got a heck of a lot bigger. There's much more focus on efficiency. Farm sizes have increased significantly as well, so we've got bigger machines, bigger tractors, fewer people working the land, and that sort of thing. I think we are probably asking our soils to do a much bigger job than we were 30 years ago. But no, I mean, I think that the understanding that soil is underpins, or good soil, healthy soil underpins agricultural production, I think hasn't really changed that much.
And what role does ADAS play then? Your organisation, what role does that play in the UK when it comes to helping farmers to maintain that asset?
Well, I think obviously we carry out research on various soils and nutrition related projects, mainly to support policy and policy implementation. I guess our main role is to be independent. We look at the evidence. It's really important, particularly in this topic area, to make sure that any decisions are based on robust evidence. And we've been very lucky over the years with the staff that we have in ADAS, and the funding and the projects that we've been able to do over several decades, to build up quite a significant knowledge base and around these topics. So I think where the provide independent advice and guidance based on evidence that's available.
That's really, that's vital, isn't it? I mean, there's an awful lot, I think, perhaps of anecdotal observation around soil, especially when we're now talking more about regenerative agriculture. There seems to be a huge amount of observation and anecdote, and I think it's the same for us here at the Allerton project, that we like to make sure that everything that we recommend is based on data and evidence and experience. I think that's very, very important, isn't it? That, not to say that those anecdotal observations are not necessarily accurate, but they do need to be backed up with that evidence.
Yeah, and I think that's one of the difficulties with this subject area, is that it requires long-term experiments, long-term projects, to understand what the impacts of different practices are on soils. And the factors that you've got to consider, weather, climate, and all the rest of it. As we've noticed this year, for example, how extreme things can be with droughts and heat and all the rest of it. And it's really important to have that long evidence, that base, that long term view of things. And as I say, we've been very lucky to have a continuum of work, but also being able to have staff that have and respected scientists that have been able to develop their careers as well over a long period of time. And I think that's really, really important, just because of the very varied factors that affect this
and the nature of the medium and the timescale.
Absolutely.
So John, we're bearing that in mind, what do you consider to be then the key principles underlying the improvement, our hoped for improvement in soil health, not just in the UK, but across Europe? We know that there's been issues around sort of soil health degradation in the last 50 or 60 years. What do you consider to be the key principles underlying the improvement in soil health? And in a way, what do you even really understand by the term soil health?
It's an interesting concept. Yeah, no, I mean, and I think it's something that it's important to give give names to things so people can understand what you're talking about. And I think it's really important just to understand what the soil's being used for in the first place, because clearly the soils have different functions. And a peat bog up on the hills of North Wales or whatever is doing a completely different function to a chalky boulder clay soil in East Anglia, and so they have different functions and have different requirements. So, and it is complicated. I mean, you have to consider the chemistry, the physics, and the biology, because they all influence each other. And certainly over the years, with the focus on crop nutrition, then we've got very, very good information on soil nutrients and the chemistry. We've got excellent guidance for that with HDB's nutrient management guide and the various other guidance that's out there, Scottish technical notes and the rest. We've got we're very lucky to have that information available to us. And similarly with the soil physics, the physics will ultimately has a big impact on the other factors as well. And certainly, as a former member of the Field Range Experimental Unit, understanding good structure, good drainage, and all the rest of it, I think people understand that as well. And managing soils and cultivate and getting the cultivations right is crucial. Now, whether it starts to get a bit harder, because ultimately to understand that, you've got to go out and assess the soil, dig the soil, and understand some of the quality indicators, where you sit in terms of benchmarking and quality, and it's getting a little bit more difficult to measure then in terms of bulk density, infiltration rates, and this sort of stuff, and soil structure. But ultimately, digging holes and having a look takes time. But it's a very valuable thing to do.
Within that framework, then, do you feel that essentially, so we've got the chemical, the physical aspects of the soil, which perhaps we understand relatively well, after many years of research. Where do you feel that we are potentially when it comes to the sort of the more biological side of our soils, and your appreciation of where that sits within a healthy soil?
Certainly, soil without organic matter in it is not soil; it's just ground up rock. So, and every soil scientist will tell you the value of organic matter when it comes to having productive and functioning soils. A soil with organic matter functions a heck of a lot better than a soil that's degraded of organic matter. We can understand that in terms of the soil structural stability, the impact on water availability, and that sort of thing. I think that's pretty well understood. And where you can manage soils to improve organic matter, then you'll see benefits in terms of crop production, for example, better rooting, better nutrient turnover. Obviously, there's a food source there for microbes and soil biota and all the rest of it to be able to do their work and to flourish. So from that perspective, I think that's pretty well understood. Once we start getting into, identifying which, I'm not a soil biologist, and I wouldn't even, pretend to be one. But it starts to get a little bit tricky then in terms of into understanding the roles that the different microbes and soil fauna and flora.
Well, this is it, isn't it? Because
but it is work that's being carried out at the moment. There's interest in that, and I think hopefully over the next few years we'll get a little bit more information about it.
Well, I think we were both involved, weren't we, with the UK Agriculture and Horticulture Development Board's, the AHDB's Great Soils Project. I think you certainly more so than me. You were an expert advisor. I was just sort of observing. And here at the Arton Project, we were involved with that project in helping develop their new soil health scorecard. But as you say, what kind of struck me in those meetings was that they were full of subject experts, but essentially it struck me that we still have clearly so much more to learn about the soil, especially, as you say, soil biology and then the complex interplay between all the different elements in what is a hugely complex system. So I guess my question would be, how do you actually understand the current level of knowledge of soil as a system with all those three different elements, physical, chemical, biological, all linking together? And what does that mean for what we're currently trying to achieve in terms of soil policy and what farmers sort of understand in terms of what they're trying to achieve? I guess that sort of famous term is, we've got the known unknowns, the unknown unknowns, and et cetera, et cetera. Where do you feel we are currently with soil now that we're setting all these policy benchmarks? We're supposed to be achieving all these great things with our soils. Do you feel that our level of knowledge and understanding, both at the policy level and at the farm level, is sufficiently there to actually enable us to be able to strike out in that direction confidently?
Wow.
In no more than 10 seconds, please.
Good question, Joe. Again, it depends what you're trying to achieve. I think a lot of this depends on what you're trying to achieve as well. I mean, in terms of within the constraints of commercial, farming operations as we have at the moment, crop production systems that we have at the moment, as I say, I think in terms of what people should be doing to support agricultural soils, I think is, pretty well understood. Maybe, in terms of the detail, and I know the devil is very much in the detail in these things. Certainly, I think, there's an awful lot more we could be looking at. Absolutely. But yeah, and one of the big challenges, particularly, I mean, for chemistry, as I say, it's pretty well understood in terms of what people are able to measure and be able to quantify, and you can put benchmarks on that. That's fine. Certainly, when it comes to soil condition, then people can understand whether a soil is compacted, what state it's in, and all the rest of it. But a lot of that time, it ends up being a subjective assessment, because it's very difficult to come up with a quantifiable definition because of the difficulties of doing the analyses and all the rest of it. And similarly for the biology, I mean, one of the really useful outputs from the HDB scorecard, HDB Soil Biology and Soil Health project was coming up with parameters which people could measure relatively easily from a biological perspective, and also that they were important in terms of indicating whether the soil was good or was in good health or not. So the organic matter, measuring for organic matter, and quantifying earthworms. There's an evidence base to back those up as being good indicators. So from that perspective, I think it is important. And then it's a question then from a policy angle. Do you need to go? How much further do you need to go? As a simple sort of scientist who if the soil's looking good, Nick, there's roots are going down, there's plenty of worms, there's good organic matter there, pH is good, and the P and K is okay, then happy days. I mean, how much further do you need to go in terms of being able to understand whether a soil is in good nick or not?
And that, I suppose, covers ultimately, we know that, again, in terms of organic matter, in terms of soil carbon, the huge difference between different soil types. Farmers on a sandy soil are never going to be able to achieve what those. But I guess what you're trying to say is that if you're adopting the good principles of soil management, ultimately, that almost negates the challenges of what your eventual sort of the eventual conclusions for your soil can be.
Well, and if you manage, as I say, managing an agricultural soil is completely different to managing a natural or semi-natural habitat as well. I mean, the principles that you would adapt when managing an upland peat or wanting to conserve a raised moss peat or something like that. Yeah. Different set of rules there. Absolutely, but what you're trying to achieve there, obviously, is something completely different to when you're managing agricultural soils. Because agricultural soils, really, we want to try and make them as productive as possible. And by and large, if they're in good nick, they will be productive. We don't want damaged soils from a production perspective, because that's compacted soils don't grow because the roots don't get down. No. So the fertilizer that you're chucking on there isn't going to get used. So you're wasting your time, basically. Yeah. You're wasting your money. And causing all kinds of issues for the environment, unless you get your canvas from an artistic perspective. As long as if you've got your canvas all nice and clean and all the rest of it, and you get the paint on, it's exactly the same as it would be with for agriculture. You've got to get the soil in good nick in order for it to be able to work properly.
And of course, that's also elements, I suppose, like drainage, the basics that we frankly don't seem to talk about very much anymore, because it's all about soil carbon and kind of the sexier end of things. But certainly within the UK, government is certainly no longer looking at elements like good soil drainage, which we know is a key part of soil health in agricultural soils.
Yeah, well, crops don't like wet feet, and I mean, certainly the way the weather's going at the moment, clearly we're having these episodes of very dry followed by very wet weather and all the rest of it. And certainly the number of wet fields sitting wet over winter that I've noticed traveling around the country recently, and it has devastating crops. If you've got crops that are sitting in water for more than a couple of weeks, they're not going to recover. and that has massive implications for the environment as well as obviously the food production and the profitability of the farm. So yeah, making sure the water gets away quickly, and managing soil structure, absolutely crucial.
Okay, just sort of a bit of a tangent here, John. You sort of mentioned, crops sitting underwater for an extended period of time, and just, I don't know whether this is your area of expertise, but one of the questions often that sort of comes up when we talk about farmland, flooded farmland, and can farmers store water on farmland, and the implications for that. Are you aware of what the implications are for long-term, flooding on farmland soils in terms of the health of the soil? Is that something that we're kind of across the detail of, or is that sort of something that you could comment on? I always think, well, what's happening to the worms? What's happening to the biology under those soils? They're submerged underwater. Are they, what are the impacts of that?
Well, it'll end up being anaerobic, and extended periods of anaerobism aren't particularly great for anything, really. But it depends how long it lasts for, what the soil type is, and what the soils have been used for previously. Clearly, if it's a meadow system with where the water table goes up and down naturally anyway, and you're not cultivated it, and you haven't planted any seeds on it, and you haven't chucked any fertilizer at it for a while, then chances are it's probably maybe it's not such a bad thing. But obviously, if you've got a spuds field that's flooded, it's not a good place to be, because obviously there's a lot of potential sediment loss, a lot of nutrient loss, etc., and certainly crop damage that you really don't want. So again, it's as with a lot of this stuff, Joe, it's site specific, soil type specific, where you are in terms of where you implement these management issues, really. And it's but generally crops don't like wet feet.
No, neither do I. So our parent organisation here at Allerton, the GWCT Game and Wildlife Conservation Trust, they recently hosted a lecture by Professor David Paulson. He's a senior fellow at Rothamsted Research. So David, and he's not alone, warned that arable farmers especially, they do need to be realistic about the volumes of carbon that can be locked up in their soils. Do you think there's a danger that a lack of sound understanding of soil and soil organic matter and soil organic carbon has led to certain parts of the industry and policymakers to get a bit carried away with what is possible in terms of both carbon trading and sort of as an industry, our potential impact on national climate targets?
Wow, nice easy questions these, Joe. Crikey. David is far more qualified than me to talk about soil carbon and the like. So I would agree with him. Basically, it's always going to be a challenge in agricultural, certainly tilled agricultural systems to build up organic matter. I think one of the main things we need to really focus on is conserving the organic matter we have in soils already, rather than to look to increase it. And I mean, if we can increase it, then that's great. A lot of the time, if we look at the evidence that Rothamsted mainly have produced over the years, then from their long-term experiments, it's pretty clear that where grassland is ploughed out, then the organic matter will drop quite significantly, over a period of time. But when you revert arable land to grassland, then the carbon picks up and builds up again. But it won't keep going forever. There will be a finite point, where the equilibrium, where the inputs manage will balance the outputs. It'll just be at a higher equilibrium than when it was in arable land. And obviously, including grass lays and that sort of thing in arable systems is also been seen as being a bit of a sore tooth in terms of when the grass is there, the organic matter goes up. When you plough it out, it goes down again, but you go down to a slightly higher level than you were before. And depending on the length of the lay, etc., then generally there's a kind of a gradual increase. But it means changing practice.
The same.
It means changing.
Well, no, I was going to say exactly in that sense. I guess that's the same, of course, across a rotation as well. Especially if you're growing root crops, I guess you're kind of trying to take, I suppose, across a a more sustainable rotation, even if you are growing root crops, perhaps 3 steps forward, 1 step back across, say, a 5 or 7 year
rotation. Yeah, absolutely. You know, and this is the thing: it's how it fits in within the rotation and that sort of stuff. Because clearly, late harvested crops, crops where sugar beet, spuds, veg, carrots, and the rest of it, where harvesting particularly late, that's always going to start causing issues for people. But obviously, if you've got better organic matter status in that soil, then it's likely to be more resilient and be able to cope with the challenges that those production systems set the soil. But yeah, I mean, this is it. Cover crops, yeah, great. But they're not so. Any kind of increase in organic matter that we're able to put into the soil, then yeah, go for it. If you have been carting the soil, the straw off on a particular field for many years, then ploughing that back in, that'll help. Small amounts here and there. But if you're wanting to make significant changes to soil carbon, particularly with animal systems, it means land use change, and you're going to have to find something to do with the grass, basically. And even if it's you go to mixed farming systems as well, which I think there's an awful lot of potential benefit in doing from a sustainability perspective, just from moving manures around and all this sort of stuff, then there has to be a change in mindset. A lot of the time, because and we are seeing it. There are people putting grass in arable systems now, partly I think because of some of the weed issues that we've got with blackgrass and that, and seeing that as an opportunity to get those under control. But unless you change your system, I can't really. Again, David knows more about it than me, but I cannot really see how you're going to be able to increase things significantly.
That does. I mean, I guess that brings up 2 key points. I mean, one thing is that I think potentially a lot of farmers and growers are getting almost slightly sick now of the term regenerative agriculture, because it's become so heavily overused in many ways. But many farmers kind of do tend to kick back with, well, that's just good traditional mixed farming, which is of course true to a point. But I look sort of back on my own experience, and on my family farm, we would probably bale up 40 or 50 hectares of barley straw a year. And then, of course, the traditional answer is, well, but of course, it's a mixed farm. It goes back on the land, and that's all good, part of a virtuous circle. But of course, that 40 or 50 hectares of barley straw would get turned back onto about 10 hectares of land. So ultimately, as you say, unless you're really integrating the livestock more into that system on a larger scale, or finding from somewhere more and larger amounts of organic materials to put back onto that land, you are still ultimately across the whole farm area potentially still mining that system, even if you have got livestock on the farm. How can you integrate them better?
No, absolutely. There is an element of robbing Peter to pay Paul, particularly when it comes to organic manures, because the manures generally are. Well, they are by and large spread onto land already. So, any benefit from that. I mean, you could argue that maybe can be spread more evenly, or, in different parts of the country now, particularly from a nutrient perspective. Most of the manure obviously tends to be over in the west of the country, because that's where most of the animals are, and probably over here in the east. We don't have much in the way of, we don't have as ready access to organic materials as we have in the west of the country. And obviously from a nutrient perspective, that causes issues as well. But yeah, from a carbon perspective, the materials are being applied to land anyway, unless we're able to find a new source of organic material, which ultimately will probably come from, waste industries, or food waste, for example. I mean, obviously there's a heck of a lot more digestate going to land now, compost potentially as well, from anything that to prevent valuable organic material and nutrients being put into landfill, and recycling those more. Then that's really only where we're going to be able to see more organic materials going to land. But even then, there are really good data which show that if you do change a practice like putting organic manures on to build the organic carbon up, then you've got to keep going with that practice, because as soon as you change, if you reverse the practice, then the organic carbon content of the soils will go down again. And so, and ultimately what you really should be doing from an organic manures perspective is, obviously the organic matter is great, and focusing where you put the organic materials, based on soil analysis from a nutrient perspective and also from an organic matter perspective. But taking account of the nutrient value of the materials, that will have a really important benefit in terms of reducing the overall carbon footprint, because you're using less bag fertilizer, and the greenhouse gases associated with the manufacture of nitrogen fertilizer and the transport of phosphate and potash and all the rest of it.
And that's a key point, isn't it? Again, if we're talking about, again, soil carbon and what we can do in terms of, becoming a net zero industry, and especially the arable sector, a huge amount of it is going to be about that nutrient use efficiency, isn't it? It's going to be about increasing, or optimizing how we utilize, especially things like synthetic nitrogen, because that is a huge part. I mean, it's 2/3 of the average UK arable farms carbon footprint, isn't it? The use of nitrogen fertilizers, and there's really only so far we can go to offset that.
And recent activity in the fertilizer market, demonstrates how important that is from an economically sustainable aspect as well. Cost of fertilizer, whatever it is now, 3-4 times what it was 18 months, 2 years ago. So having a focus on that is really important. And this kind of gets to the crux of it, Joe, as well, is that it's, focusing on one individual aspect of soil management isn't particularly helpful. A lot of the time, you've got to be able to look at it in the bigger picture so that you come up with the best overall outcome, rather than just focusing on one aspect. And organic materials, brilliant. Bulky organic manures. If I had a source of pig FYM or something like that, I'd be delighted, because ultimately I'm getting phosphate, I'm getting potash, and I'm getting this, organic material, which we have the evidence to show that it has a positive impact on soil biology. The DC Agri project that was carried out a few years ago, looking at digestate and compost use in agriculture and comparing different organic materials, compost, digestate, slurries, and FYM. Long-term experiments originally set up sort of 10, 15, 20 years ago, where we were able to continue doing measurements, and we've got some really good data from that, which has shown that compost will increase organic matter levels faster than FYM, because a lot of the FYM is got the sugars, the yummy bits that the worms and the microbes use, and that a lot of that carbon gets burnt off, whereas the compost is much more recalcitrant. The organic matter, it's been through a composting process anyway, so where a lot of those sugars have been burnt off. So in terms of building organic matter levels, compost does a quicker job than FYM, but in terms of soil biology and all the rest of it, then FYM does a better job than compost. But that's after several years of application, which from a nutrient management perspective, you probably wouldn't want to promote, because of issues relating to phosphate buildup, etc., and risks of nutrient losses that way. So it's finding a balance.
We can't have I think the term that often gets bandied about on a whole range of issues to do with this, but it is carbon tunnel vision, isn't it? We can't just be focusing on purely how can we build up the most soil organic matter in our soils, because as you say, then you run into all sorts of other problems around cost, availability, and nutrient levels, nutrient loading as well. So we have to be aware of all of these things, and we also have to be, I think, just referring back to a point you made a few minutes ago, which is really important to appreciate as well from the sort of carbon sequestration point of view, that you're not going to be adding additional carbon, achieving that additionality that we need to be worrying about when we're talking about soil carbon, and especially if you're ever thinking about trading soil carbon. If you're going to be introducing soil organic matter into your system, it has to be, as you said, new soil organic matter. You have to be finding it from additional sources, but not just additional sources to your farm, but so essentially, for us to be actually achieving anything from a climate point of view, additional sources from the industry. So yes, new digesters that are utilizing food waste that otherwise would have gone into landfill or been burned, or if you're planting, I guess, cover crops that you wouldn't have otherwise planted, and that's then putting additional organic matter back into the soil. But of course, we know that cover crops can have incredibly variable returns in terms of building up soil organic matter, depending on the soil type, depending on the farm, depending on the type of cover crops you're actually utilizing. So it's an incredibly complex issue, isn't it? It's not just
absolutely
getting a bit of extra muck and putting it on the field.
But then again, from a cover crop probably I mean, if you were looking at using a cover crop, you'd be looking to put it in somewhere where there was a risk of nitrate leaching or a risk of erosion over winter, because bare soils over winter are bad news. You're gonna lose the risk of erosion and soil damage from leaving a soil bare over winter could be significant. And if you could use a cover crop to protect it and also take up some of the nitrate, and by the way, you might increase the organic matter.
Absolutely,
then,
and that's all good for your farm carbon balance.
Absolutely. And then that means you've got more productive soil, which means that you get more better crops for the and ultimately you can utilize the inputs that you use much more efficiently if your soil's in better nick.
Absolutely.
So
it's a virtuous circle, isn't it? But yeah,
yes.
We can't just focus on one element of that. And it's the same when we're talking about food sustainability in general. We can't just be talking about carbon or even just about environmental impact. It's got to be about so many different things from profitability to social license. And anything when it comes to sustainability is such a complex issue, isn't it?
Yeah. So, I mean, cultivation practices, for example, do you really need to plow it and then smash it, go over it 8 or 9 times the rotavator just to get that really fine tilth? Or could you get away with maybe not going too deep and possibly just, plowing it and pressing it or something like that? Well, all of a sudden, okay, you might do something for the soil carbon in terms of reducing decomposition rates and stuff. But ultimately, the biggest benefit has been the saving diesel driving up and down the field, and that's win-wins again,
Well, absolutely. And here at the Allerton project, we're conducting a long-term conservation tillage trial, and we found absolutely if you compare continuous ploughing with direct drilling over a 5-year rotation so far, we're finding exactly that yes, on our heavy soils here at the Allerton project, our yield is down about 10%, but our profitability is actually up by 20% because of the huge savings in time, in fuel, and in machinery costs that we're realizing. So absolutely, there are benefits to be there, and of course, we're seeing a significant improvement in soil carbon retention, etc. So all of these co-benefits all feed into each other, and we're still essentially going out there and planting arable crops. We're just doing it in a slightly different way, and we're seeing much better financial and environmental returns. But I guess this brings me on to the next question, which is, so we're talking about soil, we're talking about monitoring it over a long period of time to see what the changes in the mechanics, the chemistry, the biology are. What are the major variables to consider when testing our soils? Because I remember my very first conversation with you was where you sort of explained to me, which I didn't realize at the time, just how variable results can be in the same field, in the same location within that field, from year to year, from season to season. So what are the main things that we need to think about when we are actually testing our soils to make sure that we're seeing a consistent set of results?
Yeah, I mean, from both nutrients and carbon clearly depend on soil type, on the texture, soil texture in particular. So sandy soils, we know that, clay soils hold more organic matter than sandy soils, and certainly the other thing that influences organic matter levels is climate. Wetter parts of the world will have wetter clay soils will have a lot more carbon in them than drier sandy soils, just because of nature and all the rest of it. So there's kind of understanding where the benchmarks are when it comes to carbon. Certainly we have good benchmarks for chemistry, as in RB209, the index system and all the rest of it. That tells us where we are. But for carbon, again, this is, I think, one of the good things that the HDB Soil Biology and Health project has come up with. It's given us benchmarks for organic matter levels based on soil texture and location and land use. Obviously, arable soils have much less carbon in them than grassland soils. So understanding what the results mean, I think, is really important as well. That's really crucial. Just because you got a sample, oh yeah, great, but what does it mean? Where are we? That sort of thing. So that's the first thing. In terms of, understanding previously, certainly when we were doing nutrient analyses, it was always based kind of like on management units. So where you could spread, where you were spreading, what you were doing, how you were managing the soils and all the rest of it. And now I think, there is potential to increase but again, it depends on the farming system. looking to see what impact whether if you've got different textured soils, in particularly across a field. So sandy soil areas like land areas, particularly areas where you've got water deposition of soil, river deposition of soils, then it could be very variable across a field. But then again, it comes down to what the management unit is. If you can split it into tram lines, then that makes life a lot easier, because it means you can vary your fertilizer rates across the field and that sort of thing. On chalk or baldy clay soils and that sort of thing, where you generally the deposition has been, the way that the soil's been formed has been slightly different. Well, very different in that it's just been sort of laid flat, then the variation is likely to be less. But understanding that is really, really important. The other thing is to make sure consistency in terms of depth in particular, making sure, particularly when it comes to organic matter, but also nutrients, going down to the same depth every time. And if you can, if you're looking to see how things change over time, is going back to the same part of the field when you're taking your samples, and clearly making sure that you get a representative sample of the area that or the management unit that you're assessing is really, really important. So, 25 cores in a W pattern, and with these kind of GPS gadgets and things like that now, being able to locate where you've taken the samples, it means you can go back to the same place. So you're making sure that you kind of not counting, the variability is reduced from year to year in terms of understanding what's going on. And
what impact is increasingly extreme seasons going to have? How much is that likely to impact any given year's results? And what if you have an incredibly wet autumn one year, incredibly dry autumn the next year? Could you see some significant differences in results there? Really throw off your sort of medium term trend?
Yeah, it's always been. This has always been one of the challenges, is when to sample and all the rest of it. And clearly, if you're doing for nutrients and things, they're making sure that it's 6 months or so after fertilizer's gone on or anything like that, so you haven't got any residual stuff there. If it's really dry, then it could be that you could easily end up with sort of anomalous results for one reason or another. But it's trying to make sure that you take the samples. When you take the samples, it's consistent in terms of the conditions that you take the samples in, because obviously that will then minimize the impact of these sort of extremes. And taking samples when it's really wet, apart from making a mess, not so sure. Taking them when it's really, really dry, immediately after harvesting, that again, it's hard work as well, which isn't helpful. But may not be representative of what's going on. So generally, sort of, moist. I know that's not particularly helpful description.
Well, the sorts of things we'd normally expect to see either in what sort of early spring or
late
autumn.
Round about now, yeah.
Back in the days when we actually had reasonable weather in the UK at least, and across Europe.
Yeah. If we ever had consistent, normal winters or summers again, that's the sort of thing. But
what sort of time scale are you realistically, if you're monitoring, say you to go out and baseline your soils, this autumn, what sort of realistic time scale, if you were to start implementing, good soil management practices, or you were trying to move towards, again, to use the term, more regenerative farming practices, what sort of a reasonable time scale would you say you're looking at, perhaps on different soil types, where you might actually start to see, a trend developing in terms of, increased soil health in terms of all the metrics we've discussed, from soil organic matter to perhaps reduced bulk density, et cetera, et cetera?
I think you've got to do it over a rotation, because the farming operations will have an impact on various practices as well. So as long as you're doing it at roughly the same point within the rotation, I don't think you'll be far wrong. I mean, after a similar crop or something like that, I think that would be that's what I would suggest. But certainly from an organic matter perspective, you're looking at least 5 years, I would have thought. I mean, you might because it depends what practice you're implementing, really. I mean, clearly, if it's putting it down to grass, then you'll see a difference within 2 or 3 years, you would hope. But if it's going from conventional ploughing to min or no till, then yeah, I think it'll probably take a little bit of a while. And the other thing to consider there is to what extent all you're seeing is a concentration of organic matter in the topsoil rather than in the top few inches, rather than it being mixed in right the way through the profile. And that's where getting the depth consistent and all the rest of it is really important, and maybe looking from that perspective. But yeah, these things don't happen overnight.
No, I mean we've been we've got a long term. So here again at the Arden project, we're on heavy clay, and we were in a very traditional cultivation techniques up until about a decade ago, and then one particular field has been direct drilled every year for 11 years now, and it's taken a decade of essentially just of direct drilling with really just returning crop residue to the field as the only significant, sort of source of organic matter to come back. It's taken a decade to increase our soil organic matter in there by about 10%. So it's a very long-term gain. Now, as you say, you could be putting compost on there, you could be grazing livestock, put grass on there, and it would hopefully have increased it faster. But yeah, 10%. So from about sort of 5 to 5.5%, 10 years, it's a long-term gain. And then you can rapidly lose that again, can't you? So again, it's all about how stable and how long term we need to be looking at, especially again if you're starting to think about wanting to trade the stuff. You have to be very careful about subsequent management techniques to make sure you don't lose any gains that you have instigated.
Absolutely, because I think this is it. What goes down is a bit like what goes up with soil carbon goes down again very quickly. so it's very much a reversible practice, and it won't infinitely rise. You will get to another, equilibrium once you go from one practice to another. No question.
So, John, if you were a farmer, put yourself in that position. I don't know if that's a dream of yours, but if you were a farmer and you had your own 500 acres of land, what key management techniques would you be applying to your soils today? So I suppose that's kind of more to say, what do you think actually works in terms of improving soil health? And over, we've kind of just touched on it. What sort of time scale would you expect to see those improvements?
Blimey. Again, it would depend on the land I had and what the soils were like to start with. Clearly, the first thing I'd want to do is make sure that I had as much information as I had about the soils, in terms of analysis and
so benchmarking really important.
Really important. Yeah, and then use the tools that we've got available to be able to allow us to understand what the benchmarking is. Where we are within the rule. Where we are, and then adapt the practices appropriately. If I was low P and K, I'd be getting organic. I'd be sourcing biosolids or poultry manure or FYM or something like that for those fields if I could. If it would be a question of understanding where it was appropriate to introduce grass and this sort of thing, again, depending on what my market was, because if I've got what am I going to do with the grass? Have I got the infrastructure there in terms of fences and water and all the rest of it to support livestock if they're in the fields? Have I got the relevant stock personship skills, which I think is really important in terms of being able to look after the animals? Because damn it, they need to be fed all the time, don't they? They need to be looked after and that sort of stuff. But yeah, basically, I mean, it's benchmarking and then getting as much information as I can, and then depending on what's available, being able to manage. I would really want to use organic materials if I could, because I think they're a really good source of organic matter, organic matter and nutrients. So to minimise the use of bag fertilizers where I could, really. And think about other things like using legumes, grass clover mixes, that sort of stuff, and taking the principles, some of the fertility building principles that would be used in maybe some of the organic systems, and I'm thinking about using those where it was appropriate. But sure. I think I'd struggle to get away from using bag. Well, you wouldn't be able to get away from using bag fertilizer, but if you can minimise the inputs a little bit, then hopefully there's benefits all around. But ultimately, got to make money as well, haven't you? You know?
Well, and absolutely, yeah. Sustainability can't just be about our environmental impact. As we've already said, it's got to be about staying in business, making money, and being able to reinvest in more sustainable farming practices. Absolutely.
Yeah.
As a final question, John, what do you see today as the biggest challenge to improving soil health? What do you feel, sort of from your experience, from talking to many people across the industry, many farmers? What's the single biggest barrier, or is there a single biggest barrier to farmers adopting genuinely more sustainable soil management practices and to really improving the health of their soils? Is it education? Is it policy? Is it finance? Where would you say that the biggest challenge lies?
I mean, I think people are doing a pretty good. I'm maybe I'm living in a lovely world, but the people that I come across and where I'm looking at it, apart from most people are doing a pretty good job, I think, or trying to do a pretty good job. Where do what to prioritize? I don't know, really, Joe. To be honest, I think I think most people. It's all.
I've put you on the spot now, haven't I, John?
It's that. Yeah, you have. Yeah, you have. I mean, it's the biggest issue really is to do with if you look at where the risks are, and ultimately it comes down to harvesting and cultivation, doesn't it? It's that sort of thing. So it's windows of windows of operation. That's where the challenges really are, because making sure that you get the soils into good nick when you're establishing the crop and all the rest of it, and also when it comes to harvesting, and particularly late harvested crops. That's where I think the biggest challenges are.
So potentially
making sure that we're able to.
I was going to say, John, so potentially then sort of the very narrow or challenging windows we're seeing around climate change are not helping in that circumstance. Yeah.
No, they're not at all. They're not at all. And also, markets and things like that as well, because clearly there is a need. Harvesting vegetables at supermarkets and all the rest of it. They want their supply when they want them, and then obviously there's the risk then of people not being able to sell the crops if they can't get them out of the ground and that sort of thing. So there is the pressure then to go on when soil conditions may not be right. And I don't know how you get around that, I'll be honest with you. And then just making sure that we're targeting these crops which are likely to cause with these late harvested crops on the most suitable soils, not putting them on the riskiest soils in terms of for particularly for erosion and compaction and that. But within the systems that we have, that's challenging, I think. So it's that's where late harvested crops are really where I think the biggest challenges are, and how to deal with those.
Potentially, then, sort of what we're looking at is in a sort of an increasingly volatile, growing climate. Planning and preparation, alongside trying to improve the resilience of your soils. It's that initial, what am I going to plant? Where am I going to plant it? What's the impact if we have a third wet autumn in a row? I think
exactly.
We were all caught out, weren't we, in 2018, and then in 2019 we thought it couldn't possibly happen again, and it did. And we were all caught out again. And then I think in 2020 we were all running in there in the middle of August planting wheat and all this sort of thing, because we were all, and of course then we didn't get that incredibly wet autumn. But it does pose huge challenges, doesn't it? This sort of increasingly volatile climate, and knowing we all know what we should be doing, but we're now starting to second guess ourselves.
No, and it puts it into focus the challenges that farmers have when they're managing their soils, and so understanding what can be achieved from a policy and from a soils perspective, in terms of whatever managing the soils is really, really important, because it has to be in that context of food production.
Sure.
Because we have to produce food at the end of the day, and there is always going to be a compromise when it comes to whatever aspect of the environment we have, whether it's air or water quality or soil health.
It's all about trade-offs, isn't it?
It is. You know, and that's the thing. But what we got to do is minimise the impact wherever we can, and that requires, I think, that requires an element of, well, a significant element of management and measuring, quantifying the variables that we know have an impact is really, really important. So doing soil analysis, doing grain analysis, even sometimes, can be valuable just in, or, understanding crop quality and this sort of thing is really, really important. Certainly testing soils, going out and digging holes. The more information you've got, the better decisions you can make for everything. But ultimately, decent soil means decent crops, means decent, as good an environment as we can possibly hope for.
No, well, that's as good a place as any to stop, I think, John. I think that's on a positive note.
Absolutely. Yeah, soils are ace. Never treat soils like dirt, basically.
That can be there it is. There's the title of this podcast. No, thank you very much for joining us, John. Really appreciate it, giving us your time.
You're very welcome.
Thanks, I put you on the spot a couple of times, but no, some great stuff come out of that, and hopefully listeners have found that really, really interesting. So thanks very much, John. That was excellent. John Williams, Head of Soils and Nutrients at ADAS. Thank you very much.